Let's have a look at question 4. It's on page 342 and 343. Exercise 8A. Find the perimeter and area of each of the shaded regions below. Okay, so I've just labelled this up. That's going to be L, our arc length, which is r theta, and that's the radius. So it's going to be 2r plus L is the perimeter. Okay, for number A, the perimeter equals 2r plus L. So that's 2 times 3 plus r theta. R is 3 and theta is in radians 0.7. So that's 6 plus 2.1. We've got an answer of 8.1 centimeters. Okay, the area is equal to a half r squared theta, which is a half times 3 squared times 0.7, which is 9 on 2 times 0.7, which equals 3.15 centimeters squared. Let's have a look at B. Now remember the B, we're looking at this arc length plus this line. Now this triangle in here, the white one, is an isosceles triangle, 2 sides equal. So if you drop this outer 2 down to here, we know this angle over here will be 2 pi on 6. We've got 7, so we can just use trigonometry to find the length of that, double it, and we've got the length. Okay, so we know the perimeter equals L plus X. Now let's construct that triangle. Okay, so that's our triangle. That triangle there is this one here. Okay, so that's X on 2 along the top. We've got 7 is here. That angle is now 2 pi on 6, right? It's 2 pi on 3 divided by 2. Now we'll just use sine. Okay, so using sine of 2 pi on 6 equals X on 2 divided by 7, which is X on 14. Okay, and so that would be 14 sine 2 pi on 6 equals X. And we said that the perimeter is equal to L, which is r theta, and r is 7, and theta is 2 pi on 3, plus X, and that's 14 sine 2 pi on 6. That equals 26.78 meters. Okay, now we have to find the area of that pink area there. Well, it's going to be the area of the sector minus the area of the triangle. Okay, so that's going to be the area of the segment is going to equal the area of the sector minus the area of the triangle. Now the area of the sector we know is a half r squared theta, and so we're going to minus that from, now we're going to find the area of that white triangle. Now the area of that white triangle is just half the base, which is half of X, times the height, and the height is, we can calculate from that triangle there, times height, H. Just write that in over here, H. Okay, so we've got the area of the sector minus the area of the triangle. It's half the base, so half X times that height, that's H. Well, that's going to be 7, that's the square root of 7 squared minus X on 2 squared, will be H. Well, that's going to equal a half times 7 squared times 2 pi on 3 minus a half. X, we said that X was equal to 14 sine of 2 pi on 6. Okay, that's X times the height, and we said the height is going to be the square root of 7 squared minus, well, it's 14 sine 2 pi on 6, well, that's pi on 3, so it's going to be, it's divided by 2, so it's 7 sine pi on 3 squared, and that's all to the half. That should give us that area. That equals 30.10 meters squared. Now C is very similar to B, okay, so we'll do that the same way. Okay, so the perimeter equals L plus X. Okay, to find X, we know that sine of 1 radian is equal to X on 2 divided by 6, which is X on 12. Therefore, X equals 12 sine of 1 radian. So the perimeter is equal to R theta, that's R times 2 plus 12 sine of 1 radian, which equals, and that's 22.10 centimeters. Okay, let's call this H. I'm on the triangle here. I'm going to call that H again. All right, well, again, the area of the segment equals the area of the sector minus the area of the triangle. Well, the area of the sector is easy. It's just a half times r squared times theta, which is 2, minus the area of the triangle is half the base of that big white triangle, is half the base. So that's half of 12 sine of 1 radian, half the base times the height. And the height is, we said, was going to be 6 squared minus X on 2, which is 6 sine 1 radian squared. All of that is to the half. So that equals 36 minus 6 sine of 1 radian times 36 minus 36 sine of 1 radian squared, all to the half. That equals 19.63 centimeters squared.